So let's go through this if we can. We're hitting the combination ones today. So let's start with number 3. A combination is an ordered arrangement. False. The combination order does not matter. A permutation order matters. Okay, stop me if you have any questions. This one right here. Did you get true for this? Because it's, and you can put it in your calculator to check, but the rule is this. They both come to the same thing. The rule is this. If these two add up to the end, then it matches. So if I do 7C4, what is that equivalent to? 7C3. Good. If I do, and this is where it's helpful, 99 things, 97 at a time, what is that equivalent to? 99C2. So that one might be easy. You know, if you didn't have a calculator, that one might be easier to work out. So that little piece of information does come in handy. Okay, number 11. Everybody good with this?
I did 13.
You did 13. Okay. All right.
I did 12.
Wow, you're all doing something different. So 12, the answer was 0.035. 13, the answer was 0.030. Okay. All right. All right, so we covered you. We covered you. Oh, for some reason. It must be fixing. Oh, this is his. All right, so then we have to do number 32. We're running down here to 32. This is important. From a group of 40 people, a jury of 12 people is selected. In how many different ways? They use the words different ways. And they want to know how many different ways can we make a jury. Does it matter what order you select them in? No. So we start out with a combination. Remember yesterday I said, ask yourself this. Order matters, yes. Permutation, no. Combination. Start with your C. 40 things, 12 at a time. Everybody good with this? Look at all the different ways you can select a jury of 12 people from 40 different people. So when you guys are 18, I think you fill out your cards to vote and everything, you could be called for jury duty. And there's a big selection process with jury duty.
Can't you get out of this, man?
You really...
No, God.
Yeah.
I know you, man.
I think you have to have a hardship case to get out, but you really, that is your responsibility, jury duty. It's part of your civic duty. A restaurant offers a dinner special that lets you choose from 10 entrees, 8 side dishes, and 13 desserts. You can choose, did we do this in class yesterday?
No.
No? 1 entree, 1 dish, 1 side dish.
We did.
We did.
Yeah.
And normally we do 1 dessert, so that was your accounting principle, right? But this one changed. This one said 2 desserts. Does it matter what order your desserts you choose? No. So that's a combination. So instead of 10 times 8 times 13, we're 10 times 8 times 13 things, combination 2 at a time. Because you can pick 2 instead of 1. In any order. Putting toppings on a pizza, again, that's also combinations. Because it doesn't matter what order you put your toppings on. When you call and get a pizza and you say, I'll take mushroom, peppers, pepperoni, it doesn't matter. They don't say, what order would you like me to put that on? No, any order. Number 37. This is also how many ways. An environmental agency is analyzing water samples from 80 lakes for pollution. 5 of the lakes have a dangerously high level of dioxin. So out of your 80, 5 are toxin, whatever you want to call it. And out of that, 75 are good. This is what you need to keep track of, this piece right here. Take it out of the information, write it out. Now, 6 lakes, kind of hard to see. 6 lakes randomly selected from the sample. Using technology, which they met your C or your P, they didn't want to have to do this by hand, how many ways could you choose 1 polluted lake and 5 non-polluted lakes. How many polluted lakes do you have to choose from? 5, and you're choosing one of them. Does it matter what order you choose these in? So start like this: 1 polluted, 5 non-polluted, 1 toxic, 5 non-toxic. So you're saying I have 5 to choose from, I want 1. This guy, you're saying I have 75 to choose from, I want 5. And when it's an and condition, we multiply. Remember? We multiply when it's an and. When it's an or, we add. When it's an and, we multiply. That gives you how many ways. Today we're going to turn those into probabilities. But so that you get to how many ways, that comes first. This one did have a probability. The U.S. Senate Committee on Ethics has 6 members, and each is equally likely to serve. What is the probability of randomly selecting the chairman and the vice chairman? Normally we say, how many ways can you select a chairman and a vice chairman? Chairman, vice, 6 times 5, 30 ways. But we ask, what is the probability? There's only one way to get that vice president and chairman. Only one person, only one way you're going to get a team. So there's your ratio, 1 out of 30. Probabilities always have to be between 0 and 1. So if you find yourself with a probability like 30, that can't be a probability. That could be your how many ways, but it can't be a probability. Make sense? Okay. Today we're hitting your probabilities, which these are a little bit tougher. Now, to me, this is the most important part, the probability parts. We're converting all your ways and things like that, using for denominators, finding your general denominators, and making probabilities. A student advisory board, again I'm on 172, a student advisory board consists of 17 members. The members serve as the board's chair, the secretary, and the webmaster. Each member is equally likely to serve in any one of the positions. What is the probability of selecting at random the 3 members who are currently serving those positions? There's only one way that we can select all 3 that are serving that, right? So setting up our probability is 1 over how many ways can I choose a chair, a secretary, a webmaster. So does order matter in this? Does it matter who's chair, who's webmaster? Yes. Order matters. Order matters because you have 3 different positions. And I signed up to be chair. I didn't sign up to be secretary. So does that make a difference to me?
Yeah.
Yes. Order matters. Yes, you have permutations. No, you have combinations. Now, your permutations, if you're doing the orders, easiest way, 3 lines. Start like this. If you don't see the P, 17, 3, 17, take it 3 at a time, go to your lines. You have 17 ways to choose the first one, then 16, then 15. These are how many ways you can choose the 3 positions. This is what you hit first. Find your bottom number, your denominator. That's how many ways. That's what we've been working on, the how many ways. So this comes to be 4,080. But don't forget they wanted a probability. There's one way that exists where you've got all 3 people. So your probability is 1 over your how many ways. Do you see the difference between how many ways and what is the probability? How many ways in this class can I select 2 people? All right, let's just say I have 24 kids. I want to select 2 students to be president and vice president of our classroom. And the president obviously has more say than the vice president, right? 24 P2. This gives me how many ways? Anybody have a handy calculator? So say I have this many ways to do this. How many? 552? Yeah. Thank you. So I have 552 ways I can choose this. Now, I get Damani as president and Aaron as vice president. How many ways can that happen? One, thankfully. One way that Damani's president and Aaron's vice president. So, what is the probability of selecting exactly my president and my vice president? 1 out of 552. Makes more sense when we kind of bring it to something closer, right? So be careful of your probabilities. You always want to find your ways, whether it's permutations or combinations, and then you have to set up your probability. Good? Okay, you guys try this one. Try it. 6. It has the same concept. Think it out. Write it down. Write them down. So, 20 members. This is Kate. What am I looking for? 2 positions. A chair and a secretary. Does order matter?
Yes.
So in how many ways can I choose those 2 people? How'd you get that? Okay, so he did 20 times 19. 20 things, taken 2 at a time. Perfect. Now, you said 280? 380, thank you. 380 different ways I can choose 2 people from 20 to be chair and secretary. Each member is equally likely. What is the probability of choosing the 2 who are currently in that position? How many ways can those 2 be in that position? 1 way. So 1 over this guy, or 1 over this one. You can set it up like this with your permutation. Yes, Aaron?
Can you keep it like that?
No, you have to resolve it to 3 decimals. Yeah. And what do you get for your 3 decimals? Thank you. Okay? Everybody seeing this? What it is they're asking? There's a difference between the different ways versus probability. And in this case, they're asking, what is the probability that you get exactly those 2 people? It can only happen 1 time. That exactly, Damani is president, Aaron is vice president. If we switch them up, then that's a different combination each time. So think of that when you're doing that. All right, so let's move along. Now we're going to hit your. All right, we're going to hit your combinations in here. Probabilities. Probabilities can be combinations or permutations. Find the probability of being dealt 5 diamonds from a standard deck of 52 playing cards. In poker, what is 5 diamonds called? A flush. A flush. So these are your chances of getting a flush. But of course it's times 4 because you can also have the other 3 suits. So whatever we find, we can times it by 4. So I want the probability. So first I want the probability of getting 5 diamonds out of any 5 cards. Out of any 5 cards. Now, does it matter what order I pick those diamonds in? Then you got combinations. Probability is part over whole. If you start like this, and you want the probability of your 5 diamonds, you're going to realize what's my denominator. Any 5 cards. Combinations, combinations. So how many diamonds are there in my deck? 13. And how many do I want? 5. Out of any possible 5 cards that you could possibly pick. So how many cards in your whole entire deck? 52. Any 5. I usually call this the generic 5. Any 5. The generic one goes in your denominator. So this is how you set up your probabilities when you're dealing with this. The ones I want over any possible 5 I could get. And you can put this in your calculator all at once. You don't have to do the first one, then the second one. Just put 13, C, 5, divide, 52, C, 5. That's easier than doing the top, the numerator, than doing the denominator, and then dividing it out. Your calculator is more exact if you let the calculator do the work. So what does yours say? It says e negative 4. Now remember, this is scientific notation. Exponent is negative 4. This is a scientific notation number. So that says move your decimal place 4 positions to the left. You can't get a probability greater than 1. So this says, and it's got to be very small, doesn't it? For this to happen, otherwise you'd be getting flushes all the time. So you're going to move your decimal place 4 positions. 1, 2, 3, 4. That means you're going to fill it with 3 zeros. And give me up to a significant digit. So give me 0.0, like in other words, don't drop it to 3 because it'll be 0. 0.005. Give me a significant digit. Remember, 0 means impossible. This is not impossible. Improbable maybe, but not impossible. And of course you have 4 other suits to choose from. You can multiply that by 4. That's your chances of getting a flush in poker. So let's have you guys try the next one. You try this. Now, be careful because they put a little twist in here. So we agree we're picking up 5 cards from a standard deck now that includes 2 jokers. So Nick and Dan, you told me how many total cards we have. 54 total cards because we're counting. So any 5 out of 54, there's my bottom number. Here's my generic. Any 5 that I should pick.
Well, it says the Joker is considered to be a wild, so what is that, 7?
No, I'm still gonna pick 5 cards. But if I'm holding like a 3 diamonds and 2 jokers, that I can have 5 diamonds.
But the jokers represent any card.
Any card you want. So if you pulled the joker and you're looking for a diamond, then that joker counts as a diamond.
So
altogether, let's do the bottom. Altogether, you had 52 cards plus these 2 jokers that we're dealing from, right, Damani? Now, the top part. How many diamonds in my deck? 13. So should I write 13C5? No. 15. Why? Because my jokers would count as diamonds. So now it added to me, in this case, 2 extra diamonds because I'm looking for diamonds. See it? No, because the bottom I'm choosing out of, well, I did change it from the other problem. The other problem we chose out of 52 cards. Now you have 54 cards to choose from. If I spread out 54 cards, I say choose any 5. Any 5. That's your generic. 5 out of any 54. The part you want is 5 diamonds out of your possible 15 right now because those 2 jokers just bought you 2 more diamonds.
No, I just want to know about that.
Yeah, bottom 54. I have 54 playing cards now. This comes out to be 0.00094. Again, if you want to go to 0.00009, that's probably more exact. Or if you go to 001, that'll give you the 3 decimals. Okay? All right.
15.
I'm sorry?
13,
13 plus your 2 jokers. Your jokers can act like they're 2 diamonds now.
Okay.
If you were sitting in your hand with 3 diamonds and 2 jokers, you're going to count them as diamonds. So it just bought you a little bit more. Okay. Do we have time for one more? I think we do. I think we have time. Okay, let's hit this one. Okay. One more, guys. One more. This is a good one to get under our belt. A food manufacturer is analyzing a sample of 400 corn kernels for the presence of a toxin. In this sample, 3 kernels have dangerously high levels of toxins, same as we did before. So start like this. 3 are high-level toxins. Therefore, how many are not? Out of your 400. 397. Always start like this. You have to see your breakdown. 4 kernels are chosen at random. You want to choose 4. What is the probability that exactly 1 kernel contains a dangerously high level of toxin? First of all, let's go for the bottom number. This is probability. How many do I have altogether to choose from? And how many am I choosing? 4. Any 4. That's my bottom number. Doesn't matter if they're toxin or not. Any 4 that I choose. That's my generic number. On the top, I want 1 toxin, and therefore how many not toxins? 3 non-toxins. Does it matter what order I choose those in? So, for combinations, how many toxins do I have to choose from? 3. I want 1. How many non-toxins do I have to choose from? 397. And how many do I want? 3. I want to add up to 4, don't I? Right? Now, it's an and statement, so I'm going to multiply. So here's my top number. Okay? Now, be careful when you put this in your calculator. This has to be in parentheses. Otherwise, actually no, it would work. Well, it would work this time because ordered operations will multiply and then we'll divide. But always if you have more than one, you should group it with parentheses. And whoops, that number comes out to be 0.030. Tomorrow, guys, we'll finish. We'll start with the try it one, and then I'm going to give you an assignment in class.